Now, in this presentation, I'm going to take a question that borders on centripetal acceleration. Now, a horizontal turntable has a block of mass m kept at the edge. If it starts rotating from rest with a constant angular velocity omega, we are to find the friction force between the block and the table, that is the table surface, and then determine the coefficient of friction mu. Now, okay, this is another case of a body moving in circular motion. But there's a disc, as you can see, let's say turntable. I'm sure I've seen this before in those days. And this turntable is free to rotate in this direction. Now we have this as the axis of rotation, this line. And you can see the direction of the angular velocity. Alright, so here's the body of mass m, and this turntable starts rotating from rest. That is to say, the initial angular velocity will be zero and the initial linear speed will be zero since it starts rotating from rest. And you can see this R stands for the radius of the turntable. Okay, so when this turntable starts rotating, let's say with a constant angular acceleration until it attains, let's say, a maximum speed, angular speed maximum, or until it attains a maximum linear speed, v is maximum. It started from rest, then turns or rotates with a constant angular acceleration. Okay. Now we are told to find the frictional force between the mass m and the surface of the turntable. Okay, so now very quickly, you need to understand again that though in my previous videos I explained that when the body moves in a circle like that, it requires what we call the centripetal acceleration. That is the force that keeps the body moving in its circular path without skidding, without veering off the path. And the centripetal force is always directed in the same way as the centripetal acceleration. Let's call this one AC. My centripetal force is FC, okay? Because from Newton's second law of motion, the centripetal force is responsible for the centripetal acceleration, AC, okay? So, and without this centripetal force, this body will not remain on the turntable while the turntable rotates with a constant angular velocity, which means we can see that the frictional force, the friction or frictional force between the body of mass m and the turntable provides the centripetal force that is needed to keep the body in motion on the turntable. So the frictional force between the two masses, or let's say the mass and the turntable, provides the centripetal force. That means there's a particular speed this is rotated, and what happens to this mass? It flies off the surface of the turntable. It may be because of the fact that the frictional force is not enough to provide for the centripetal force. Okay, so we can say that the frictional force F, which is equal to mu multiplied by normal reaction, because this normal reaction N is the same thing as the weight of the mass M. So I can say that this is equal to mu. Mu is the coefficient of frictional force. Of course, you know from the laws of solid friction that the force of friction for solid friction now is directly proportional to a normal reaction. So that gives you mu, and my normal force is mg. So I'm going to equate that to my centripetal force. That is m. Maybe I can use omega squared multiplied by the radius of the turntable. Okay. So, but if they ask for the frictional force, since we don't have all this, I can replace this and see my frictional force F is equal to mu, or sorry, mass multiplied by this, because the frictional force equals the centripetal force. Okay, so this is the expression for the frictional force. And if I want to find the coefficient, maybe if I'm given the mass of the body, maybe let's say 10 or 20 grams, of course, must convert that to a kilogram. You'll be given the angular velocity, let's say 10 radian per second. You square that, you'll be given the radius of the turntable, let's say 10 cm. You change that to meters and then evaluate the frictional force. Now, suppose I want to write an expression for the coefficient of frictional force between the turntable and the mass. I'll come back to this equation. I have my mu, which is the coefficient of static friction, is m, omega squared r divided by mg. Of course, I know that this mass is the same as this, so they both cancel out. So the coefficient of friction gives me omega squared multiplied by the radius of the turntable over g. This our g is called the acceleration due to gravity. So this is expression for the coefficient of friction. Okay, and you need to note that if this speed, or let's say the angular velocity, starts increasing beyond the limit that is sufficient to keep this mass on the turntable, which means if that increases, the centripetal force will have to increase. So centripetal force F, remember I told you that is provided by the frictional force. Okay, let me call that Fr, which is my frictional force. That gives me m omega squared r. So if the angular velocity increases without the frictional force increasing, or so to speak, it means that this mass may not remain on this turntable. Because if I increase this angular frequency, I need this to also increase, because this is what provides the centripetal force Fc that is necessary to keep this mass m on the turntable. So increasing this without increasing the frictional force, so which means that's what we call the limiting frictional force. There is a maximum frictional force that is needed to maintain this body on this table. If this value of omega, whatever it is now, exceeds the maximum frictional force, the limiting frictional force, it means this mass will leave the table, the turntable, in the direction along the tangent, as we can see. So it takes off along this direction if the angular speed increases, okay, and the frictional force is not sufficient to provide the centripetal force. Okay, look at this other question. Let's solve this quickly. This one has some parameters given to us. So a block of mass 3 kg is attached to a string having a length of 40 cm. If the block is wired in the horizontal circle that it completes 20 revolutions in 1 minute, the question says determine number one, the angular displacement, determine the angular velocity, and so on and so forth. So let's write down the parameters given this question. The mass of the block, that is 3 kg. Let's write it down. We're also given that the length of the string, of course, I always say the length of the string equals the radius. Okay, let's say this is a block of mass, or so to speak, in this my diagram here, mass m, which is 3 kg. Now the length of the string equals the radius of the circle. That is when this string starts rotating, or when the block of mass starts moving in this circle, then the length equals the radius. So I need to express that in meters. So that will give me 0.4 meters, because I'm giving the length of the string as 40 cm. Now if the block is wired in a horizontal circle complete 20 revolutions, number of revolutions is 20, and in 1 minute, so the time is 1 minute. Okay, first of all, we need to determine the angular displacement. Now for this angular displacement, that is theta, we use this symbol for angular displacement, is equal to number of revolutions multiplied by 2 pi. Why is this 2? Because when n is 1, for one revolution, the total angular displacement described by the body when it makes one complete circle is 360 degrees. And 360 degrees in degrees is equal to 2 pi in radian. So that's why we have this pi here, because I already said here that this theta is always measured in radian. Okay, so that will give me 20 times 2 pi radian. That will give me 40 pi radian. Okay, so that's this total angular displacement. Then the angular velocity omega is angular displacement total divided by the time. So we have this as 40 pi. I want to leave my answer in terms of pi. The time was given as 1 minute, so I'm going to change that to 60. That's 60 seconds. That will give me 2/3 pi radian per second. Okay, so that gives the angular velocity. And if pi is not needed, maybe they would want you to use 3.14 as pi, or 22/7 as your pi. So you make substitution there and get the actual value of the angular velocity. Then the linear speed v is equal to angular speed multiplied by the radius of the circle. So that will give me 2 pi, or 2/3 pi, multiplied by 0.4, because we are given 0.4 meters. Of course, we did that conversion for the radius of the circle. So if I come in here, the linear speed is omega multiplied by this. That gives me 2/3 pi times 0.4. Okay, okay, that will give me 0.8 pi over 3 in meters per second, where pi is 22/7 or 3.142. Okay, the next question says calculate the centripetal acceleration. That is A. I can use either omega squared r, or I can use the equation as centripetal acceleration is v squared divided by the radius of the circle. So it depends on what I want. Now, if I want to use the first equation, I'm going to have 2/3 pi all squared multiplied by the radius 0.4. So I'm going to square this, and that gives me my centripetal acceleration in meters per second. Can we do that with your calculator? So the centripetal force F is given by mass times centripetal acceleration. So I'm going to have the mass is 3 kg multiplied by 2/3 pi all squared times the radius 0.4. Okay, so you get your calculator, simplify that, and get the final answer for the centripetal force. Okay, next video will take more questions on this circular motion or cases of centripetal acceleration.